Okay, we have a MacBook Pro. It's 14 inches. The model number. Uh, so this is a 2442, and it says no power. So just something to mention regarding the 14 inches as well as the 16 inches. So there's been a bit of a difference in the charger communication behavior. So for example, in the previous design, in terms of when in the previous design, as you know, with the USB-C designs, you need a 20 volt from the charger. You need 20 volt from the charger, from which the device will basically work from. Now, sometimes, so the 20 volt circuitry, it's separated from the other section of the board. Say for example, if all the working condition of the 20 volt circuitry it's in place, you will get 20 volt. Now that may also, I mean, even though there is 20 volt, you may not have PPBUS voltage on the machine. You may not have other power rails on the machine, but you will have 20 volt. Now, with the newer design, especially, which is also one of the reasons why it's good to use your Maxif 3, um, your Maxif 3 when you're working on those devices. Now, with this newer designs, especially with the Max, with the what I have found with the 14 inches and the 16 inches, if you have an issue that is not directly linked to your 20 volt power line into the machine, you will not have the communication line, which is the lead on your charger. Now, if you use a USB-C charger, you will be getting 5 volt instead of 20 volt. Now, the problem, even though you may not necessarily have a problem in the PPDCN circuitry, do you understand? So in previous design, this is only subject to if you have a problem within the within the PPDCN circuitry, then you will have less than 20 volt. You have 5 volt. But in this case, you will have an issue outside outside PPDC in circuitry, but still the device will be either stuck on 5 volt, or in case of when you use a Maxi 3 charger, you have no LED on the charger. So that's just the difference that we have noticed on the machine. So yeah, now let's continue. So and then as you guys know, with no power devices, we do not connect power to it until we are sure of what state the device is in. So first thing first, let's take the back cover out. Okay, the back cover is out. Uh, this looks very clean. We do not see any sign of liquid whatsoever. So the next thing we're going to do is to disconnect the battery. So in our previous video, we spoke about the dual battery connection, where you have a data line for the battery, which you have a cable in that place, and then you have a main battery power line. So this is the data line for the battery. So we are going to disconnect that first. And that is basically a general rule. Whenever you take out the back cover of a machine, the first thing you want to do is you want to disconnect power from the machine before you do anything. So we do not have to disconnect the main battery power line, which is this here. Yeah, but because we are going to do that anyway, the board is going to go out, so that's why we are removing the main battery power line. Okay, so with that out, so we are going to do basic measurements. We are going to leave the small meter basically for continuity measurement, and then we leave the big multimeter for voltage measurement as well as your direct board measurements. So first thing first, we have let's place our black probe on ground and then our red probe. Let's see what you have on our PPBUS. Interesting. So the first measurements we basically doing it's on the PPBUS, and then we can hear a big beep on the PPBUS line, which means we have a short on the PPBUS line. So let's take the board out, and then we take it off from there. This looks very clean. I mean, no, okay, no, but no, but there has been an attempt, so that seemed to be broken. So which means somebody was here before. That is expected because this has been previously assessed, and which is how they came to the description that it's a no power. Okay, so let's take the board. Let's take the screws out, and we are going to be needing a T4 screwdriver as well as a T5 slash T6 screwdriver. Let's quickly go over the T4 screws first. And then another thing I also would like to point out is that whenever you're working on these devices, especially if it is your first time, you want to make sure you take note of what is what and where is it's what, so that when you are putting the device back, you have a better idea. So usually what I would do, for example, if this is like when I'm working on a device and it's my very first time, it's like a new design type of. So what I will do is I'll take a photo of it, put the photo aside. So just to give me an idea of what it were before the board goes out, and then that will help me when I'm putting the board back to know where they're supposed to go into. So I like to say that each step you try as much as you can to make sure that each and every step of the way, your decision or the actions that you carry out are basically based upon a reason. So if you need to replace a component, if you need to whatever it is that you need to do when a repair is concerned, make sure that there is a proven reason why you're doing that. You don't just go ahead and do it, and you don't apply general troubleshooting tips, or you don't apply general troubleshooting process across the board. So, for example, you may see how okay, that would probably have to use a bigger T5. So also that. So if one method works on a particular machine, that is because that is what is required for that machine to work. So it's not like every description that says, for example, no power or no backlight, you have to use the same method that was used for a no. Yeah. So whatever method you're taking, it has to be backed up by a reason, not just because it's a no backlight, so this is how you fix no backlight. Okay, now time to disconnect the cables. And I advise that when it comes to the cables, you have to be very, very careful, especially the touch ID cable as well as the angle sensor cable. And then the reason why that is, especially those two cables, are because those two are tied to the board. if any of if they are broken, you have to go through a great deal of trouble to basically run a jumper wire to reconnect the cables. So you want to make sure that you are very careful, and even though you are using a tool, make sure that your tool it's in full control. So yeah, the less you actually use a tool, the better. But if you do need to use a tool, make sure you are in full control of the tool, not allowing the tool itself to take control. So screws are out, cables are out, and then also while the board is out, while you're trying to take the board out, try to wiggle a little bit just to be sure that all screws are out. Now because we have a gap here, and because the HDMI port is on the side, and the HDMI port makes its way through the chassis, so we are going to take the board out from the side. So we will basically be using, because here we have a space here, so we have a gap here, so the board will have to go out from this side. Now, as we are lifting the board, we are looking for any form of resistance, and making sure that. So, say something like this. What you want to do is okay. So, if that doesn't go out, well, what we can just do is apply, say, alcohol there, for example, to soften it up, and then you take it out. So, okay, the board is out. Now we are going to observe the other side of the board, and before that the board number is going to be 820-02098. 820-0298. Okay, so it's and then we did confirm that we have a short on our PPBUS. We did measure here at the fuses, the dual fuses that we have here, where it says PPBUS underscore AON, which means always on. So that would mean that's a voltage that should always be present regardless of the power source to the device, whether it's your battery or your charger. That is that voltage is required to always be on. So we did measure that we have a short on that PPBUS line. So let's try again, because sometimes you may have the case of a trackpad. You may have the case of the short coming from the trackpad, because there's also a direct line for your trackpad for your PPBUS. So what I'm trying to say is, let's see, where's our trackpad connector? This guy here. So here you see we have, so on pin 3, on pin 33, 34, 35, 36, 37, 38, 39, 40, you have your PPBUS line. So sometimes you may have a situation where the issue is on your on your trackpad, so that can cause also a short. So now that the board is out of the shell, if our problem was from the trackpad, obviously the short should be cleared. So let's try again. We have our black probe on ground. That we can use that as our ground. Let's try again. So we still have a short, so which definitely means that our short is on the board and not on the chassis. So the next thing we're going to do is to flip the board over to see if anything stands out. So we usually like to start from one side onto the other side. So let's start from this side and then move to the other side. Oh, okay. We don't even have to look further. That is our problem. That is our problem. And yeah, so that's our problem. And the concept of controlled damage, or the concept of internal damage. So it plays plays an important part, especially when it is stressed that before you connect power to a device. So I'm just gonna explain something to you guys. So let's say this is the component that is damaged. It's a flip the board to the other side, and that is going to be where's the where it should be, and say yeah. Okay, this is this guy here. So C5, C5840. Now, the concept of, so if we go to, so let's say, let's go to the schematic and then go to C, okay, even, yeah, let's go to the schematic real quick. And our board here again is 02098. 02098. Okay, there you go. Let's check again. What is the cap is 5840. Okay, let's say 5840. Oh, C 5840. Okay, so this is the cap here. Now that cap it's sitting on the PPBUS line. Let's just quickly go. Is that a PPBUS line? I'm just gonna go. Okay, no, that cap is sitting on 3.3 volt line, but obviously because there is okay, let's go back and let's try to make sense of that. So this the cap is sitting on 3.3 volt line, not directly on a PP bus line. However, that cap 3.3 volt line makes its way to PP bus. Let's say through this guy here, ROD59, ROD D590, which is a current sensitive resistor. Now, if we remove RD59, RD590, the short will be cleared from the side of the PV bus, and then we will have a short on just this only. Now, so the concept of contained problem. So the concept of a contained problem is this. So as long as there is no continuous power supply onto this line, the issue will remain here. As long as there is no constant power supply, the issue will remain on this cap because this is the cap that is damaged. Yeah. Yeah. Wait, why do we have multiple C55 840? Oh no. Okay. Yeah. Okay. Okay. Now I think this is the guy. Yes. This and that not present on the line. Okay. So this is our guy. Yeah. Now, but then we see that we have a line, and on that line it's PP3V3 underscore AON. Now, so long there is no continuous power supply onto this line, the issue will remain here and here alone. Now, when you now send power through it, even though you already have a damage here, the chances of this spreading across every of its connecting point is very high. Do you understand? So you started with just a problem here, but then if you keep sending power to that line, what's going to happen is you basically keep you will get an extension of that issue onto say like because say for example if you come here now, so here we know that we have a problem just here, yeah, but then if you keep sending power here, this is already damaged. The next thing to be damaged will probably be then this or then that or this or then that. And then remember also you have more communication lines here that is made possible by ROD 5590. So the point I'm trying to make is it's not ideal to connect power to a board without having to understand the state of that board. Do you understand? So that's why I say every step that you take in your troubleshooting or in your repair has to be informed. There has to be a reason why. So you cannot just do it without having to have a reason why you're doing it. I don't know if that makes sense. Okay, so let's go back to this and let's take that out. Okay. Okay. Let's get a donor board to get a replacement for it. And that's a tantalum capacitor, and also it's also a polarized capacitor. So by polarized capacitor, it means orientation wise. um, yeah, so you have to make sure you follow the orientation. Unlike a capacitor like this is non-polarized, which means you don't have to worry yourself about the polarity, or you don't have to worry about the direction. So this, however you place it, can place it either way, you're fine. But when it comes to polarized cap, you have to make sure that you follow the direction of the capacitor. Okay, that's out. Okay. Okay, let's see if we still have a short on our PPBUS. It's just a test for ground. Okay, that's beautiful. Our short is gone. So yeah, yes, we no longer have a short on that line. That's very good. So the next thing we want to do now is to test our board now. Then now is the time that we can conveniently basically plug a charger to the machine. Up until now, as you guys saw, we did not plug power to the machine. So to install the board back, we are going to basically follow the same procedure as taking out the board. Did he come to collect or he just he brought something? Usman know what to do in assisting him? Hmm? What? I said, does he know what to do to assist him? To assist him. So first we are going to test it. We hope our problem is solved. Okay, now we can plug power to it. We have charger communication, which is a good thing. And that is it. That's a beautiful Apple logo. So we're not going to wait for this to complete booting. Let's just shut it back down because we do not want to write. Yeah. So because we don't really want to review client's data. So that's done. The next thing we're going to do is quickly put the screws back in place, and yeah. more. Okay, I'll look for that. Okay, we're just going to do a quick sweep to be sure all screws are in place. That includes all cable being in place. Okay, so the next thing we want to do now is to connect back the battery data cable. So you make sure that the first thing that gets disconnected from the machine is the battery, and it is the last thing that you connect before you close the backup of the machine. Also be aware of the different lengths of the screws. They're not all the same thing. So that the longer screws for this ones will be on the top, and then the shorter ones will be on the bottom. Okay, there you go. We're not going to wait for you to boot up. Let's quickly shut it down. Okay, thank you guys. This is going to get cleaned and then finalized, and yeah, we will have a happy client. Thank you guys. I'll see you guys in the next one.